Okay, are you guys done? See, can you see the screen? Tell me.
Yes, sir.
Yes, sir.
So no doubts from the assignment?
No, sir.
No, okay, fine. So, before going anywhere, I need to make one correction from the last class. Okay, one correction from the last class. So write one correction or addition, however you want to write this. That on the addition of inert gas, no? Regarding the addition of inert gas, on addition of inert gas, there is no change in, okay, on addition of inert gas in constant volume. At constant volume, there is no change in the concentration of product or reactant. Hence, there is no change in state of equilibrium.
Sir,
Yeah, tell me.
could you please repeat, sir? I was searching for my books.
क्या repeat करें आप बताइए?
Did we stop at Bronsted-Lowry acid-base concept last class?
Yeah.
This is the conclusion.
No, this is not the conclusion. This is one correction that I have to make from the previous class. Okay, and addition of inert gases. When we are talking about inert gases, now I got that. Okay. So in that we wrote that there will be a change in state of equilibrium. That is not taking place because we are just adding an inert gas. We are not changing the concentration. So there are two ways in which you can increase the pressure. So if you add a gas, then there is only an increase in pressure. But if you add a gas which is accompanied by, if you, no, sorry, not add a gas, if you are increasing the pressure like this, now there is a change in volume also. There's a change in volume. So if volume will change, what is going to happen? The concentration will change. Now in here, what is happening? You have number of moles that is not changing because that is inert gas is added. It is not going to react with anything. The number of moles of all gases will be same. And if the volume is not increasing because it has at constant volume, the volume is also same. And that is why the K will be also same. But in this case, if we are increasing the pressure, then the volume is going to decrease. The number of moles will be obviously same, but this will lead to a increase in the concentration. Increase in the concentration, right? If the concentration is increasing, that means the K is going to change. So if we have a constant volume and if I add a inert gas, in that case there will be no change in the equilibrium state. Okay, there will be no change in the equilibrium state. Is constant and is also constant.
Sir, one doubt.
हाँ बोलिए.
Sir, will the equilibrium constant change when the direction of the reaction changes? Like when you increase pressure, the direction will change. So will Kc change then?
If we are increasing the pressure, which is accompanied by the change in volume.
No, sir. If you increase pressure, sometimes the direction of the reaction will change, right?
The direction will react. The direction of reaction will change, obviously. So what is
Then
going to
will
happen then?
Then will the equilibrium constant change?
It depends on the equilibrium constant actually, no? See, and it also depends.
So do you understand my question?
On the, I mean, how the reactants and the products, what are the stoichiometry there? I understood your question. Let me elaborate on that. Okay. And see. So there is some pressure. Okay, there is some pressure and there is some volume. Okay, so if I am changing the volume,
you were stuck.
Am I not audible?
Now you're audible, sir, but you were stuck. Can you explain again?
No, I did not explain anything. Okay, fine. So we have this reaction in which we can see that let us suppose that all of these are gases. Okay, all of these are gases. Now what I'm doing, I'm increasing the pressure by decreasing the volume. Fine.
Yes.
Yes. So there will be more products that will be formed. C will increase.
Yes, sir.
right? If the C is going to increase, then obviously the concentration of C is going to increase, and the concentration of A and B, what is going to happen? Tell me. Concentration of A and B will
Decrease.
concentration of A will decrease, and concentration of B will also decrease. Okay, so now you can say that the product concentration is increasing and the reactant's concentration is decreasing. Correct? Yes or no?
Yes, sir.
So what will happen to K? K will increase, right?
Yes, sir.
You know. So it depends on like stoichiometry and where do we have more number of moles and where do we have less number of moles, all those things. But if I just reverse this reaction, if I write the C as a reactant and A and B as the product, then the K is going to decrease. So obviously, yes, K is going to change if I am changing pressure. That is why there are some reaction which is done in high pressure to get some moles of gases. Okay. For example, if I talk about this process of N2 and H2, no? So this is done in very high pressure. So if it is done in very high pressure, then the equilibrium shift towards the product side, and we only get ammonia. We don't have this N2 and H2 if I will increase the pressure. Similar is the case with temperature also. Okay. So let me know if you're done. Then we can move on to the advantages of Bronsted-Lowry concept, and then some limitations. And then we will move to acid-base concept according to Lewis concept of acid and bases. Can I move? Atif, Mariam, Sarah.
Yes, sir.
So right, advantages of Bronsted-Lowry concept. Okay. So number one advantage is that it is going to explain some of the basic character which Arrhenius. Okay, whatever advantages I'm writing now, this is with respect to the Arrhenius concept. Okay, so according to Arrhenius concept, if I see NH3 is not going to be a NH3 is what? NH3 it should be. NH3 should be an acid, but it is not, right? It is a base. So it explains, right? It explains basic character NH3, then you have Na2CO3, etc., which don't have OH negative, which don't have OH negative groups. Because according to Arrhenius, what should happen? Only the molecules and ions, only the molecules which have OH negative, they should be a base. Okay, they should be a base. But NH3 and Na2CO3, these things they don't have any OH negative group. Here is the second point. It is not limited to molecules. Is not limited to molecules, but also tells about acidic and basic character. Acidic and basic characters of ions, right? So for example, if I look at let us say NH4 positive, right? Then I can say that it has only the tendency to lose H plus ions, right? It has only the tendency to lose H plus ions and it will become NH3, right? So this is an ion, NH4 positive. It is acting as an acid, right? It is acting as an acid, right? The third point, it explains acid base character in non-aqueous medium 2. In non-aqueous medium 2. That means Bronsted-Lowry concept, it did not have to take the help of water. Because if I look at the Arrhenius concept, Arrhenius said that acid is anything which liberates H plus ions, when it is added on water. So it was water dependent. The definition was dependent on water, but Bronsted-Lowry did not have any such limitation. They said that anything which gives H plus, it is an acid. If it abstract H plus or it takes up H plus, eats H plus, it is what? It is a base. So write these 3 points down. Let me know if you're done. Then we will move towards the limitations.
Done, sir.
All of you done?
Yes, sir.
Sir, wait, I just and zoom out.
And you take a screenshot of this. This is a correction, okay? From the last class, one correction from the last class. So take a screenshot from here. Done? Can I move down?
Yes, sir.
Write this.
So can I ask one more doubt?
Bolo na. Tell me.
So in the recent assignment, there was like a question to find the conjugate acid base pairs, right? So is there any way to identify like which one gives both acid and base?
Okay, if you can see there is some hydrogens, so you can remove the hydrogen. So that will be an acid. For example, HCO3 negative. Okay, HCO3 negative. Can I remove a hydrogen from HCO3 negative? Tell me.
Yes, yes.
So it will act as what? It will act as a acid, right? If I can remove H plus, that means it is acting as an acid, correct?
Yes, sir.
Now tell me, can I add H plus? Yes or no?
Not sure. I think
Not sure.
no.
Okay. Can you make the structure of HCO3 negative?
Sorry, sir.
Can you make the structure of HCO3 negative? Lewis dot structure?
Yes.
Yes or no? You can, if you can make Lewis dot structure, then you will be able to see. Okay. So main
Okay,
thing
sir.
is the Lewis dot structure here. So let me show you. So if you make the Lewis dot structure, it will be something like this. Okay. When I say Lewis dot structure, I am not making dots. Okay. If I can make like this, oxygen, and negative charge here, and there is a hydrogen here. So this is HCO. This is HCO2 negative, right? HCO2 negative, HCO3 negative. Okay, this is HCO3 negative. Tell me.
Yes, sir.
So if I will add H plus, I will get yes or no?
Yes, sir.
Right. But if I remove H plus from here, then I will be getting yes or no?
Yes.
Okay. So this is something that you have to try and see whether you can add or subtract something or not. Lewis dot structure, it is going to help you in the addition of H plus ions and also in the removal of H plus ions. Okay. Fine.
Yes, sir.
Okay. Now let us write the limitations of. Right next, limitations of limitations. Bronsted-Lowry. Okay. Limitations. First of all, it does not explain the acidic character. Okay, it is acidic and basic character. Acidic and basic characters of non-metallic oxides and metallic oxides respectively. Okay, second point is that second point does not explain the acidic and basic characters of non-metallic oxides and metallic oxides respectively. Second point, okay, some reactions I have to give. So for example, if I take a metallic oxide such as CaO and it reacts with SO3. Okay, so this will this metallic oxides, these are what? These are basic in nature. This will act as a base, this acts as base, and this acts as acids. Now there is no involvement of what? Any H plus ion, any proton, but still this is an acid-base reaction and it will be forming CaSO4. So the Bronsted-Lowry acid-base concept, it does not explain these type of reactions. Secondly, it does not explain the acidic character of substances with incomplete octet. Substances with incomplete octet. Okay, for example, BF3, BCl3, AlCl3. Okay, these things. Okay. Muhammad Umar, you asked me a few questions now.
Yes, sir. Last night?
Last night.
Yes, sir.
Is that clear now?
Sir, not yet. I'm trying to
Not-
understand, but it's incomprehensive.
Why? What is incomprehensive? The delta Ng?
Yes, sir. I mean,
What is delta?
let me check the question again. Wait a second.
Yes, others, please let me know if you're done. Okay.
Done, sir.
Done. Okay.
So in the
Yes, sir.
product side, there should be 3 moles, right? In the product side.
Why 3 moles?
Because
3
there
moles
are
of what? 3 moles of what?
1 mole of nitrogen, 1 mole of carbon dioxide, 1 mole of water.
Yeah, there should be 3 moles, correct. Okay, then what are you saying?
But we proceeded by taking only 1 mole on the product side.
How many moles did we take?
1 mole.
1 mole. I think we took 2 moles.
Sorry, yes, 2 moles, sorry.
2 moles. But I did not take 2 moles of anything. Na? I did not say it has 2 moles of product. What are we finding? Delta N,
Delta Mg.
Ng. What is G?
Gas.
So I have to see the change in number of moles of gas, right? Yes, Umar?
Yes, sir.
Okay, so you have nitrogen. And so if I have to look at gases, that means I'm talking about states of matter. And I have to also look at the temperature, right? Yes or no? If I
Yes,
want
sir.
to consider the state. What is the temperature given in the question?
298 Kelvin.
Now you tell me nitrogen. 298 Kelvin means what? In degrees Celsius, you tell me. If you understand 298. Yes, Muhammad Umar.
Can you repeat?
What is 298 in degrees Celsius?
198.
Huh?
Sorry, 98.
नहीं पता ना फिर आपको 25 डिग्री सेल्सियस. Yes or no?
Yes, sir.
So अब बताइए आप, है ना? You have to look at the states, है ना? Important thing is that the NH4CN na, that is solid, and water is liquid. Okay, so that is why we don't take those moles.
Okay, sir.
That's
Okay.
what I said in the I actually said these things only na in the chat.
I didn't got any chat.
You did not receive anything?
No, sir. I just got one chat which said that there are two nitrogens in NH2CN.
Acha, after that you did not get. Okay, fine.
No,
Actually,
sir.
I replied very late. That is why I think Nishka sir did not send you. Okay.
No.
You understand?
Yeah, now I
Want the
understand. It's because of the states. Okay, I understood.
Yeah. Okay. Now, right, limitations are done. Now, right, Lewis concept of acid and base.
Can you scroll up for a second?
Thoda sa. Okay. Yes. Atif done.
Yes, sir. Done.
Yeah. Right. Next, Lewis concept of acid and base. Okay, Lewis concept of acid and base. So Lewis, what he did, he boiled down the concept of acid and base to the flow of electrons, because what are all the reactions? They are just flow of electrons. He said that acid, what are acids? Acids, they accept pair of electron. Any substance that will accept pair of electron, that is going to be an acid. Okay, that means it is a electron pair acceptors. Electron pair acceptors are acids. And what are bases? Bases is anything that donates pair of electron. And electron pair donor. Okay, so electron pair acceptors are acid and donors are bases. Acceptors are acids, donors are bases. As electron pair acceptors are acids and electron pair donors are bases. So for an acid will be A. Now this base, it should have a unshared pair of electron that it can donate to an acid. It is going to give you a product like this. Okay, so we can essentially generalize all the reaction into acid-base reactions. Okay, and we can say that this here is an acid, since it is accepting pair of electron, and this is a base. And more importantly, these are Lewis acids and Lewis bases. Okay, Lewis acid and Lewis base. Now, if I will categorize the Lewis base, then you will most prominently see only two categories of Lewis base. Lewis base. Okay. So there will be two categories of Lewis base that you will most prominently see. There will be neutral atoms. There will be neutral molecules or atom. Neutral species with at least one lone pair. Now, here the concept of Lewis dot structures, they come very handy. You have to also know about, the valence electron, right? So if I just write NH3 now, if I just write NH3, and you will see, sir, kahan hai electron lone pair? No. So there are lone pairs. Nitrogen has one lone pair. Similarly, if I will write about H2O, so oxygen has two lone pairs. If I will write about any amine group, NH2, here also nitrogen is having some lone pair. If I will write about alcoholic group, ROH, so here the oxygen, it is having lone pairs. Okay, it is having lone pairs. So here the Lewis dot structures, they come very handy. You have to know the structures and you have to know where are the lone pair electrons. Okay, so you'll not be given every time like this. The lone pair electrons shown very explicitly. The next items are negatively charged species, or you can say anions. Okay, you can say anions. Okay, anions such as, for example, you can write Cn negative. Now, even if this is an anion, still the sharing of electron will be through the unshared pair of electrons, Okay, so here carbon and nitrogen both can donate electrons. Similarly, you will have Cl negative. Now, Cl negative will have 8 unshared pair of electrons, out of which it can donate any one of the pairs. Similarly, you will have OH negative. Now, in this OH negative, now the oxygen will have 3 pairs of unshared electron, and there will be a negative charge on the oxygen atom. So these are anions, and there will be neutral species. So whenever you are asked to choose a Lewis base, then what you are going to see, whether it has a lone pair or no. If it has a lone pair, that means it is going to be a Lewis base. Okay, and if it is an anion, then obviously it is going to be a Lewis base. So tell me if you are done. Then we will discuss about Lewis acids.
Done, sir.
Done, all of you?
Wait a minute.
Done, sir.
Yes, Mohammed Umar, write this down. Let me know if you're done. Then we will move to Lewis acids.
Done, sir.
Done? Okay. All right, next. Lewis acids. So Lewis acids can be categorized into 3. Okay, Lewis acids can be categorized into 3. First type of Lewis acid will be the molecule with incomplete octet. Okay, they will have incomplete octet. Okay, incomplete octet. What does that mean? It means that it will be having less than 8 electrons in the valence shell, those molecules. For example, BF3, right? BF3 has 3 bonds. 3 bonds means 6 electrons. 6 electrons means less than 8. That means incomplete octet, and it can easily accept an electron. It can accept an electron. Similarly, AlCl3. Okay. What else do you have? You can have FeCl3. So these are the examples where you have incomplete octet. Then there will be simple cations. Okay, simple cations. So in simple cations, not all the cations, they have a tendency to accept electrons. Okay, all of the cations don't have a high capacity to accept electrons. For example, the alkaline metals and the alkaline earth metals, group 1 and group 2, they have the tendency to lose electron. So if I will take the cations of those elements such as sodium positive, calcium 2 positive, so these will be what? These will be less acidic because they don't have much tendency to accept electron. But if I talk about some other examples such as the cations of D block element, they have higher tendency to accept electrons. Similarly, you will have H positive. So H positive also, it has higher tendency to accept electrons. Then moving on, after the simple cation, you will have some molecules which will have empty d orbitals. Okay. Mridula, she's not our student. Lewis acids. Okay. Now after simple cations, you will have, hi Mridula. You are here for which class? Very good. Empty d orbitals. If you have molecules which have empty d orbitals, that means they can accept electrons. If you have any empty orbitals, they are going to accept electrons. So Lewis acid, the main criteria, if I look at the main criteria, it is the empty orbitals. So incomplete octet, again, you will have some bits of empty d orbitals such as silicon fluoride. Okay. Other examples would be if you have SnCl4 and if you have, let us say, PF5. So all of these are examples. All of these are examples of empty d orbitals. Where do you find empty d orbitals? Group 3 and onwards, right? Group 3 and onwards, you will find empty d orbitals, because in the first and second shell you don't have any d subshell, but in the third shell you have the d subshell. Okay. Then the last is if you have an atom, atom connected to more electronegative element, more electronegative atom via multiple bond. So these are the 4 cases. These are the 4 cases that will give you a Lewis acid. The example will be CO2, SO2, etc. Okay, so these will be the examples. So I will give you examples of reactions in all of these cases. First of all, write this down. Let me know if you're done.
Done, sir.
Okay. Is there anyone who is still writing?
So I'm writing the last one.
Okay.
Done, sir.
Okay. So Muhammad Umar, you let me know if you're done. Okay. Yes, Muhammad Umar, done.
Done, sir.
Okay. So let us see if you have a simple reaction. This is one of the most important reactions that you will see. That if you have BF3, so boron has trigonal planar structure, if you remember from molecular structure, and it will have a p orbital which is empty, right? Because it is 1s2, 2s2, 2p1. Promotion of electron. So there will be a bond with fluorine here. There will be a bond with fluorine here. There will be a bond with fluorine here. This is going to be empty. Now in this, what we can do, we can put electrons here. So if I have NH3, let us say, and NH3 has a lone pair electron. Okay, it has a lone pair electron. And please remember, NH3, it is not, you can't say that it is electron deficient, because it has a complete octet, because nitrogen, there are 3 bonds. That means 6 electron, 7 and 8 electron of the lone pair electron. So what will happen? This lone pair electrons will attack and it will get inside the BF3 empty p orbital, and you will be making a molecule like this: nitrogen, just giving electron to boron, and now both of them are. And if you remember this now, then I have written this reaction in the chemical bonding structure also, in the chemical bonding chapter also. So write this down, and we have also determined the hybridization also. There is an NCERT question on this, chapter number 4. Let me see, did we do this? Dipole moment, I think in hybridization somewhere we did. So it is always a good thing to go back and see your notes. Formation of ethane. Okay, this, why it's so small? Is that question? I did not discuss in that class. Okay, I will find it. Don't worry about that. Because I remember there is one question that which we have done. The question is something like this, that what is the change in the hybridization of nitrogen and bromine and boron in this reaction, if it is going to have this reaction? There's one question in NCERT that I discussed. Okay, fine. So you write this down. This is one example of a Lewis acid and base. In this, you can see what is happening. The BF3, it is acting as an acid because it is accepting a pair of electron, and NH3, it is acting as a base, as a Lewis base. So this is Lewis acid. This is Lewis base. This is Lewis base. Okay, so write this down. Let me know if you're done. Other example you can write, if you have carbon dioxide and you have some OH negative atoms, then what is going to happen? This OH negative atom, it is going to attack on carbon and will be making O negative, and there will be OH. This will be attacking here carbon, and this bond will be getting broken and it will go to O negative. Okay, so write this down. Let me know if you're done. Then we'll write some questions on the identification of Lewis acids and Lewis bases. Done, guys?
Done, sir.
Okay, is there anyone who's still writing? No? Okay. Write a question. Identify Lewis acids and bases in following. Okay, Lewis acids and bases in the following. Okay, write these four only. So OH negative, it is an anion, right? It is an anion. That means it will be acid or base. Tell me. Base, right? It
Base.
will be a base. Very good. What about F negative? Acid or base?
Base.
Base.
Base. What about H positive? As acid or base?
Acid.
Acid.
Right. BCl3,
Acid.
acid or base?
Acid.
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 Acid. What about H2O?
Base.
Base. Okay, fine. So this is about Lewis acids and bases. Okay, this is about Lewis acids and bases. Now let us write a few remarks regarding all of these acids and bases. Okay, Bronsted, then we have Arrhenius, and then we have Lewis.
Can I write it? So can I write this down?
Sorry.
Can I write this down?
Right. Likhe. Hey, when I write the question, you write that time down, na?
Done, sir.
All of you done? Mohammed Umar, let me know if you're done, okay?
Done, sir.
Okay. Write some remarks. First point is all Arrhenius acids are Bronsted acids. But all Arrhenius bases are not Bronsted bases. Okay. How? You can write an example. If I look at NaOH, so it has OH negative group. That is why this is Arrhenius base, right? But it can't accept H plus, right? And that is why not a Bronsted base. Okay, that means there are few molecules which are Arrhenius. All the Arrhenius acids, they are Bronsted acid because the definition is same. Arrhenius said that liberation of H plus, Bronsted said also for acid liberation of H plus. But the definition changed if I look at Arrhenius and Bronsted, if I look at the bases of Arrhenius and the bases of Bronsted-Lowry. Okay, next point is that right here, all Bronsted bases are Lewis acid. Sorry, all Bronsted bases are Lewis bases. But all Bronsted acids are not Lewis acids. Okay, are not Lewis acids. For example, let us see HCl. If I will have HCl, what is going to happen? Plus H2O is going to liberate into H3O positive plus Cl negative, right? Plus Cl negative. So in this case, we can see that the Bronsted acid, that is HCl, is a Bronsted acid. So an acid, according to Lewis, what it should do, it should accept electron, but HCl is not accepting any electrons, right? What it is doing, it is just giving out proton. It is just giving out proton. So write this down. It is not accepting anything from H2O, right? It's not accepting any electron from the H2O. Wait a second, let me reshare this thing. Syncing, and that's why. Yeah. Write this down. Let me know if you're done.
Done, sir.
Okay. So now these are the basics of ionic equilibrium. Okay. The acid-base concept and the definitions of acids and bases according to Arrhenius, Bronsted-Lowry, and Lewis. And you need to remember all of these things. Okay, you need to remember whatever we have learned till now. These are the alphabets of the things that we are going to do from now. Okay, so these are not concept. These are just definitions that you have to remember. If I will say that, if I come and argue why this is A and why this is also A, these two things look very different to me. And these two things look very different to me. So why should I agree that both of these things are A? So you can't argue on these things. Okay, so why? Because we are basing our whole study on these particular pillars as alphabets. Alphabets makes English language. So these acid-base concepts, this will be making the ionic equilibrium. So you need to memorize this. You need to memorize this. And for example, if I talk about calculus, and if there is a person who does not know multiplication, he is going to fail in calculus. But if somebody knows multiplication, it is not enough to know multiplication to know calculus. But if somebody does not know multiplication, he's definitely going to fail in calculus. So similarly here also, this is the most least part that you can do to understand the ionic equilibrium. Okay, there will be 1 marks question from what we have learned. The journey begins now towards ionic equilibrium and towards understanding of ionic equilibrium. So in ionic equilibrium, we will be mainly dealing with acids and bases. And if acid and bases react with each other, they'll form salt, right? So we'll be dealing with acid, bases, and salts, which are again formed with acid and bases. So directly or indirectly, we are just dealing with acids and bases. Okay, acids and bases. Now, but acid and bases, if I just talk about HCl now, so HCl is not acid on its own. HCl is acid only if I add this to water. Okay, if I add this to water, fine. So first of all, we have to know this solvent, our solvent, the solvent that is water. So first of all, we'll have to understand about water. How is water on its own? And what is some properties of water? What are some properties of water on its own? And what happens if I add an acid to water, and what happens if I add a base to water? Okay, so now the understanding part is coming. Now the understanding part is coming. So first of all, what is water? Is water an electrolyte? Okay, if it is an electrolyte, whether it is weak electrolyte or strong electrolyte. Okay, so first is this question we are going to answer. Is water a strong electrolyte or a weak electrolyte? So the answer would be, does water conduct electricity? My answer will be no. Water, the pure water, H2O liquid, it does not conduct electricity. So according to Faraday, we will say that it is not a strong electrolyte, it is a weak electrolyte. It is a weak electrolyte. And if it is a weak electrolyte, then there will be an equilibrium like this. There will be an equilibrium like this, that H2O liquid, please don't write this, plus H2O liquid. If I will have two water molecules like this, they can ionize into H3O positive in aqueous and OH negative in aqueous state, right? It can dissociate into HCO positive and OH negative, both in aqueous phase, fine. Now, obviously, this is not a strong electrolyte. That means it is a weak electrolyte. So what will happen? We can write an equilibrium reaction here, okay, an equilibrium reaction. Next thing is that if I want to write the equilibrium constant for this, then I have to write, what will be in the numerator, guys? Tell me. What will be in the numerator? Concentration of वाह, equilibrium constant expression भूल गए क्या आप लोग? H3O positive into concentration of
OH negative.
OH negative, very good, OH negative, and divided by concentration of H2O square.
Yes, sir.
Yeah, H2O square. But we also know that since H2O is a liquid, so now comes the time then when I have to explain you why do we take the concentration of as solids and liquid, pure solid and pure liquid as one. Why do we take that? It is because, let us talk about two things. Let us see that if I have water here, okay, if I have water here, initially we had 100 grams of water. So 100 grams of water will take 0.1 liter. Yes or no? 100 ml, na?
Yes, sir.
The volume. Okay, then there's some reaction happened, and okay, let me just make it a bit easy. This is 2 and this is 2. 200 gram, 200 ml, and this got converted into 100 gram. So the volume also changed just to 100 ml. Yes or no? Any problem here? Tell me, guys. Any problem?
No, sir.
No, sir.
No problem. Okay. Now what I am going to do, I am going to consider the A and B. That is the concentration in both of these cases. So concentration will be number of moles. So a number of moles is what? The given mass. The given mass is, initially it was 200 gram, divided by the molar mass, that is 18, divided by 0.2 liters. Yes or no? This is the A case. So I can write this as 200 upon 18 into 0.2. Right? This is the given mass, molar mass divided by volume. Given mass by molar mass will give you the number of moles, divided by volume will give you the concentration. Any problem?
No, sir.
No. All of you? Omar, Atif, Aisha, okay, Mariam said no. Reba and Surat, what about you guys? Any problem here?
No, sir.
No, no, okay, fine. For B, you tell me then. What will be the concentration in B? How should I write that? What is the given mass in B? What is the given mass
100.
here? 100 divided by 18. This will give me the number of moles divided by 0.1 ml, 0.1 liter, right? Yes or no?
Yes, sir.
Yes, sir.
Okay. So again, I can write 100 upon 18 into 0.1 liters. So here also you can see that I can rewrite this as, if I divide by 2, this will be 100 divided by 18 into 0.1. So you can see that even if there is a change in mass, which is accompanied by change in volume, that is why there is no change in the concentration. Can you see this? Both of these things are equal. Concentration at the position A and the concentration at the position B. Huh, guys? You can see that, right?
Yes, sir.
So the concentration of pure liquids and pure solids, they will not change, because if the mass changes, because essentially mass changes when we react, the mass becomes low, but it is also accompanied with the loss of some volume, and that is why I can say that the equilibrium constant here, it is equal to the concentration of H3O positive into the concentration of OH negative, and I can write this constant. Okay, you don't write, I will write this as constant. You don't write. I can say that this K into this constant, this will be equal to concentration of H3O positive, concentration of OH negative. Yes or no? Any problem here?
No, sir.
No. Now this K and a constant, this is known as Kw. OH negative. Okay. Now this is known as the dissociation constant. Okay. Kw is known as the dissociation constant of water, or the ionic product of water. Kw is also known as ionic product of water. Okay, so all right here, ionization constant of water. Okay, and then you copy these things down. Let me know if you're done.
Done, sir.
Is there anyone who is still writing?
Done, sir.
Done, all of you?
Done, sir.
Okay, Surat is not done. Surat, write and let me know if you're done. Surat, you let me know if you're done. Okay, देखिए आराम से. Fine. Okay, now this Kw is a equilibrium constant. Okay, and it is dependent on temperature, because all the equilibrium constant, they are temperature dependent. If I will change the temperature, the equilibrium constant is also going to change, because there will be a shift in reaction towards forward or backward direction. Okay, so right here, Kw is an equilibrium constant Kw is an equilibrium constant and Kw is an equilibrium constant, and at 298 Kelvin, its value is 1.008 into 10 to the power minus 14. No, 10 to the power minus 14. So we just write that the Kw, it is equal to, if I want to write it simply, then I will write Kw, it is equal to 1 into 10 to the power minus 14. Acha. There will be mole square and liter square, because we have two molar concentration here, liter inverse square. we will simply write that kW is equal to 10 to the power minus 40. Okay, 10 to the power minus 14. This is something that you have to memorize. This is going to help you guys. This is going to help you guys. When I said now in equilibrium, in Ionic equilibrium, we are going to introduce a term that is going to help us to calculate the concentration of equilibrium and concentration of Ionic equilibrium. That is this term, the new term that we have introduced, that is Kw. And we already know this value, 10 to the power minus 14. It is not going to change. If we have the temperature at 298 Kelvin, it is not going to change. Okay, right? Next point, that is K is temperature dependent. Kw is temperature dependent. And it increases. And it increases with increase in temperature. Increase in temperature as dissociation of water, as dissociation of water is, as dissociation of water is endothermic. Endothermic. Write this down. Let me know if you're done.
Done, sir.
Okay, is there anyone who is still writing? Let me
I'm
know,
back.
please. Okay. Done?
Done, sir.
Okay. Can I move? Yes or no? Tell me. Umar, are you done? Yes, Umar, are you done? Is Umar not here? Okay, I think he's done. Right, next. Let us see the extent of this reaction. Okay, let us see the extent of this reaction. So we have H2O. Okay, we have H2O plus H2O. It is giving me H3O positive plus OH negative. Okay, plus it is giving me OH negative. So let us say that this is undissociated water and this is dissociated water. Undissociated water and this is dissociated water. Okay. So if I talk about the concentration of concentration. Oh, wait a second. Wait a second. Okay. We have this reaction that is H2O plus H2O. It is giving me H3O positive plus OH negative. So from this I can say that since we are getting 1 mole of H3O positive and 1 mole of OH negative, that means there will be equimolar concentration. H3O positive and OH negative, they will be present in same amount. Yes or no? Tell me. In pure water,
Yes,
I
sir.
can say na.
Yes, sir.
In pure water, H3O positive, concentration of H3O positive and OH negative will be equal. Okay, will be equal. So I can say that the concentration of H3O positive into the concentration of OH negative, that is equal to 10 to the power minus 14. I can say that this is X into X, which is equal to 10 to the power minus 14. And X square is equal to 10 to the power minus 14. and x will be equal to under root of 10 to the power minus 14, which will be equal to 10 to the power of minus 7. Correct? And hence I can say the concentration of H3O positive is equal to the concentration of OH negative, which is equal to 10 to the power of minus 7. But please remember, this is what mole square and liter inverse, right? And if I just give a root inside this, then it will become mole per liter, because 2 by 2, and this is also 2 by 2. So mole per liter. So both of these concentration will be 10 to the power minus 7 moles per liter. Okay. So write this down. Let me know if you're done.
Can you scroll up?
Scroll up. This is the reaction, na?
So I just
H2H2O.
wanted to get reaction.
It's a reaction.
So you can also write it as molar raised to -1, right?
Sorry, m raised to minus 1. Yeah. M raised to minus 1. You can write that. Yes, guys, are you done? Let me know, please, if you're done.
Done.
Done. Okay. Now we can say that this is the concentration of undissociated. This is the concentration of dissociated water. And if I talk about the concentration of H2O now, then I can write the concentration of H2O. Please refer to the chapter 1 in which we have calculated the molar concentration of H2O. Does anyone remember what is the concentration of H2O? Nahi. How many moles of water is there in 1 liter of How many moles of H2O in 1 liter? Does anyone remember this? No. Okay, 55.56 moles per liter. Do you guys remember this value by any chance? देखा भी नहीं लग रहा आप लोगों को? Oh my God.
No.
हाँ, आपको तो नहीं लगेगा, आपने पढ़ाई नहीं है हमसे चैप्टर 1. I am asking students like Abhinav and Mariam, Reba. Yes, Mariam, you said something?
Yes, I remember, sir.
Number dekha लग रहा. Okay, fine. So if I want to calculate the ratio, na, then I can say that undissociated water, dissociated divided by undissociated. This will be equal to 10 to the power of minus 7 divided by 55.56, right? And this will be what I can say, 10 to the power of minus 7, and I can say this will be equal to 0.55. I will write this as into 10 to the power of 2, right? And this will be equal to 1 upon 0.55 into 10 to the power of minus 9, because it will go up. Yes or no, guys? So, and if you can see this is almost half. Can you see that this is almost half? 1 upon 1 by 2. Can I say that? Yes or no?
Yes,
Tell me.
sir.
Okay, so can I write this as 2 into 10 to the power of minus 9? Yes or no? Tell me.
Yes.
Okay, so now you can see that dissociated water is this much and undissociated water is this much. So which is larger, dissociated or undissociated? Tell me. Which is higher?
Undissociated.
Undissociated. Okay, and Hence, I can say that since undissociated water is very high in concentration, the equilibrium will lie towards reactants or towards undissociated water. Okay, so write this down. Let me know if you're done. Then we are going to look at what is going to happen if I will add H plus and what is going to happen if I will add OH negatives, if I will add an acid or if I add a base. Done, guys? Please write this down. Let me know if you're done.
Done, sir.
That's
Okay, is there anyone who's still writing? What happened, Aisha? Are you not well?
no, sir. Actually, I'm just having cold.
So I hope you're taking medicines. Did you go to doctor?
Yeah.
हाँ, एग्जाम के टाइम में प्लीज बीमार मत पड़ जाइए, है ना?
Mhm.
एग्जाम के टाइम में प्लीज बीमार मत पड़िए, ठीक है?
Yes, sir.
अरे भाई साहब, ओके ओके, ऐसे कोई खांसता है हमको डर लगता है जूम से भी कुछ हमको आना जाए। फाइन, मास्क लगा के बैठो यहाँ पे भी। ओके, so now we are going to look what is going to happen if I add an acid and what is going to happen if I add a base. Okay, if I add a base. Now, rather than saying add acid or add base, I can first of all write this equilibrium H2O, which is going to have H plus and OH negative. Okay, I hope all of you are fine with this simple representation. Yes or no, guys?
Yes, sir.
Okay, fine. Now let me say what is going to happen if I'm going to increase H positive. So what is the human doing? Human is increasing the H positive. अरे भाई, ओके, आप बहुत ऑर्डर मारती हैं घर में आयशा। Increase H plus, okay. So what is going to happen to the reaction? It will shift forward or backward? Backward, right? आतिफ, आपने क्या कहा? Backward ही कहा ना सबने?
Yes, sir.
आतिफ, backward ना आतिफ? आतिफ ने नहीं कहा backward, आतिफ अब सोच में है। Yes, आतिफ? What happened? I don't know whether he can hear me or not. Okay, increase in interest, the H plus, that it means it will go backward. Okay, it will go backward. Fine, it will go backward. Now let us see what is going to happen to the concentration of H plus. What is going to happen to the concentration of H plus with respect to the concentration of OH negative? Okay, with respect to the concentration of OH negative. So let us say that we added. Let us say we added. Okay, I'm not going to do it like this. I'm going to give you pure numbers. Then we will see what is going to happen. H plus is there and OH minus is there, right? So when there was nothing and it was pure water, then we had 1 into 10 to the power of minus 7 molar concentration of H plus and 1 into 10 to the power minus 7 molar concentration of OH negative. Please don't write this, please listen. Now what I said, I added H plus. So let me say that I added 9 into 10 to the power minus 7, 9 into 10 to the power minus 7 molar concentration of H plus, and I did not add anything in the OH negative. So at what is going to happen in this case, if I add this two, then I will say that it is, see, 10 to the power minus 7, 10 to the power minus 7, I will take that as common, and 9 plus 1 will be equal to 10, and this will be 10 to the power of minus 7 only. Now H plus has become how much? H plus has become 10 to the power of minus 6, and this has become 10 to the power of minus 7. Yes or no, guys? Any problem till here? Tell me.
No, sir.
No, sir.
No problem. No problem. Okay, fine. Now at this point of time, I have added something. That means I will calculate the Q. Q yaad hai na, reaction quotient. Let us say that this is QW. Hai na? I am calculating the dissociation constant of a particular reaction that is happening. So if I will calculate, this will be 10 to the power of minus 6 into 10 to the power of minus 7, which will be equal to 10 to the power of minus 30. Yes or no? 6 plus 7. Yes or no, guys?
Yes, sir.
Any problem? Okay. But the Kw, it is how much? Kw, it is equal to 10 to the power of minus 14, right? And since Qw ऐसा कुछ होता नहीं, okay, you will not see this in ebook, but for this case, an example for understanding 6, I can write Qw, okay? So I can see that Qw is greater than Kw or less than Kw, you tell me guys. कौन बड़ा है, Qw या Kw? Which is larger? Qw is larger, right? Now, if Qw is larger, that means what will happen? Reaction will go backward. Any problem, guys? Tell me. The same thing
No,
happened.
sir.
Na? We started with qualitative understanding, and now we have put in some numbers, and we have got the quantity also, and we say that it is going to be, and reaction will go backward. Okay, fine. So let me again write H plus and OH negative. Let me again write H plus and OH negative. Okay, H plus and OH negative. Now, in this case, what I will do, I will write here 10 to the power of minus 6, which is the current concentration of H plus, and 10 to the power of minus 7, which is the current concentration of OH negative. Now, if I will write the change, then see, both of these are going backwards, right? They are going to form water. So if X moles of H plus is reacting, then OH minus will also be minus X, yes or no? Tell me. X moles of OH negative, equimolar?
Yes, sir.
Yes, sir.
Yes, okay, fine. That means I can write at equilibrium what is going to happen. I will have 10 to the power of minus 6 minus some quantity, and I will have 10 to the power of minus 7 minus some quantity. Yes or no? Tell me.
Yes,
Yes,
sir.
sir.
This is going to be happening at equilibrium. Yes or no? At equilibrium, है ना?
Yes.
Okay, now you see these two, 10 to the power minus 6 minus some quantity x, and 10 to the power minus 7 minus some quantity x. Now you tell me which is higher? Which is higher? H plus or OH negative? कौन सा वैल्यू हाई है? ये हाई है या ये हाई? -6 वाला या -7 वाला?
minus
हाँ, ठीक से थोड़ा सा जो भी बोला थोड़ा जोर से बोल लीजिए उसको. सही कहा है आपने.
-6.
-6 1. All of you understand this? Yes or no? Tell me. Atif,
Yes, sir.
है ना? मरियम, मोहम्मद उमर, उमर अब्दुल्ला, सूरत,
Sir.
है ना? So the concentration of H plus will be higher. Okay, got it?
Yes, sir.
All of you?
Yes, sir.
Okay. Now this seems very intuitive कि हम acid डालें तो H plus की concentration it will be higher. But what is count? I mean, what you can't see is that the concentration of OH negative also decreases. Yes or no? This was not very visible na, when we were adding acid. That concentration of OH negative, not relatively speaking, it was 10 to the power minus 7. It will be less than 10 to the power of minus 7. Yes or no, guys?
Yes, sir.
Okay, so if you are adding H plus, then there is two things which is happening. There are two things which is happening. You have the concentration of H plus, which is rising, and then you have the concentration of OH negative, which is decreasing, and that is why the Kw it is going to be constant. है कि नहीं? Yes or
sir.
no? Okay. Now see, this
Sir,
is
the
very important.
principle-
आप बना दीजिए, आप आतिफ प्रिंसिपल बना लीजिए, है ना? Why you have to learn this as principle? It is according to Lee-Chatter's principle because it is going backward, but you know that already, है ना? Yes or no, Atif?
Yes.
है ना? You said backward according to the Lee-Chatter's principle only, ना? ये तो आतिफ से सवाल पूछो, शांति हो जाता है एक सवाल पूछ के. Yes, Atif, can you hear me? Hello.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. Okay, fine. Okay. Now, see, this is very important to keep this in mind because kabhi aap aise, like if you are flipping your pages, hai na? Today, now it is January, it is going to be January, and your exam is in February. If you're revising equilibrium chapter, hai na? Then you will see that if I will add acid, then the concentration of H plus will increase. Hai na? I'm not adding anything else. So what should happen? The Kw should also increase because I am just increasing the concentration of H plus. So why does the Kw does not increase? It is not increasing. It is not increasing because the concentration of OH negative is decreasing on the addition of H positive. Remember this point. It is very important. Okay. Now you can write. You understand all of these points. Then I will start writing now. You can just copy it. Okay. The conclusions. I will not let you write the whole thing that we have explained. what we can do, we can just write the conclusions. So first of all, write the topic addition of.
Ma'am,
Ma'am,
we didn't have to
ma'am तो है
write.
नहीं. नहीं,
We didn't have to write what you wrote about, sir.
वो मैम बताएंगी आपको. मैम बताएंगी आपको, अपने मैम से पूछ लिया. एडिशन ऑफ एसिड्स एंड बेसिस इन वाटर. Acids and bases in water. Okay. Okay. Number 1, addition of acid. Addition of acid increases the concentration of H positive and decreases the concentration of OH negative, है ना, which leads to Kw equal to 10 to the power of -14, that is constant. So Kw नहीं change होने का है. Kw is not going to change. Okay, Kw is not going to change. And at the end, you can say that the concentration of H positive in, if you have an acid, then it should be greater than the concentration of OH negative. Okay. Second is addition of base. So in addition of base, what is going to happen? There will be an increase in the concentration of OH negative, and there will be a decrease in the concentration of H positive, which leads to Kw be equal to 10 to the power of -14. That is constant. And in this case, the concentration of OH negative, it is going to be greater than the concentration of H positive. Okay, write this down. Let me know if you're done. Reba, you understood now whatever I explained previously?
Yes, sir.
So if you have understood it, then try to write in your own words. Okay. Try to write that in your own words. Main thing is the first line that we have, increase in the concentration of H plus on the addition, and there is a decrease in the concentration of OH negative, which leads to the Kw equal to 10 to the power of -14. Okay, which is constant.
Thank you.
Then all of you?
So
Yes.
Martin.
Okay, okay. I will wait, no problem.
Done, sir.
Just wait a second. Okay. Now write the pH scale. You know the pH, right? What is a pH? You have heard this word, no? I'm just asking.
pH scale.
Yes, sir.
Yes, sir.
pH scale. Okay. So what is the pH? What is pH? pH is the negative logarithm of molar concentration of H3O plus ions. Potence hydrogen. One of the alleged, I would say, one of the alleged full form of pH is potence hydrogen. Actually, the word P that is written before hydrogen, so it has kind of history with it. It has kind of history with it. Like P was the word, like in, I think in French, German, and Danish, because I think pH was introduced by a Danish chemist. I don't know his name actually, but he was a Danish chemist. So the P word in German, I think it is potence, and in Danish, I think it is something like potent or something. In French also, it has some word which is P. All of they mean power or potential. Power or potential. So just to compromise with everything and to give each country their own. French and Germans, they were very much affluent in science at that point of time. But the chemist who was coming up with this idea was a Danish chemist. So he has to choose one letter from the alphabet, which did justice to all of these three communities: the French community, the German community, and the Danish community. That is why he chose P. But he also did sometimes write as a QH. Okay, if I remember it correctly. Sometimes he wrote for a particular acid pH, and for some he used the letter Q. So there is some history. You don't have to know about that. Okay, fine. So pH is the negative logarithm of molar concentration of H3O positive ion. That means, what is pH? pH is equal to minus of negative logarithm. Logarithm means base 10. Okay, logarithm means base 10 of molar concentration of, that means concentration of H3O positive ions. I know. And this can be also written as 1 upon, and pH can be also written as, so yeah, I don't know whether how many of you know this, log of 1 upon. How many of you have studied log? Tell me now, raise your hand. How many of you are comfortable with log?
Sir, I have studied, but I'm not comfortable.
Okay, what about others? Atif, Aisha, Mariam, Reba, Surat.
Do I have to memorize the log table?
अरे log table क्यों memorize कीजिएगा?
No, until 10. Till 10.
हाँ, नहीं, no. You just have to memorize 4: log 2, log 3, log 5, and log 7. That's it.
Log 2, log 3, log 4, log 5, log 7.
नहीं, log 4 नहीं. Log 2, 3, 5, 7. The first 4 prime numbers. The first 4 prime.
So why specifically these 4 numbers?
I will tell you. Then you can derive the other things. Okay, I will tell you how.
Okay, sir.
Okay, 2, 3, 5, and 7. So let me know. I will teach you log for a bit now. I think no one knows log, but
You
it is
sent
just
a
like
PDF, right? From Boston.
वो PDF,
University.
Boston University I sent, but किसी को तो कोई तो किया नहीं होगा ना.
No, I've gone through it.
Did you do the exercises?
1 or 2, sir. 1 or 2 or 3.
Exercise 1 or 2 questions.
Yeah, from the PDF itself.
Okay, but nahi, means if you do the whole thing na, then it is going to help you. Then it will stuck in your mind. तो
It's better
बोलिए.
if you teach us.
I'm going to teach you. Can I move? Yes or no?
Yes, sir.
Okay, fine. All of you,
Yes, sir.
I have to teach you log ना. आप लोग को log नहीं आता. If there is someone who knows log, and if you want to leave this right now, you are free to leave. Okay, because I'm not going to teach you chemistry. I'm going to teach you log. So for
we have
log,
done-
हाँ बताइए आतिफ.
Yeah, in our school we have done log before. We did some questions, but I don't remember most of it now.
अच्छा, so you don't. Okay, fine, no problem.
Yeah,
If
for
you
us
want
in
to
exam,
study,
they'll give us log tables. We can calculate from that.
honestly speaking, I don't know how to use log table. Okay, I have never used log table, and I don't know how to use log table. I just have committed to my memory these 4 values of log, and that's it. I don't need anything else. Okay, and you won't be also needing anything else to solve any problem, whether it is of log or anti-log. Okay, whether it is log of or anti-log. First of all, let us come to what is the basic thing that you have to remember. So for log, you should remember one thing. And whenever I'm saying log, I'm saying with the base of 10. Okay, base of 10. You will understand what are these things slowly. But log of base 10, which is equal, and let me take log of 100 to the base 10. How we say this? Log of 100 to the base 10. Log of 100 to the base 10. And this will be equal to. So how you calculate this? So you tell me 10 to the power of what will be equal to 100?
2.
All of you agree? Yes or no? Tell me.
Yes, sir.
Yes, sir.
So this is log. Okay, fine. जो भी यहाँ पे base होगा ना, whatever the base is here ना, then you will whatever, and you have writing equal to, so you can convert this to, if I will write is this as, let me see, I say that log of 100 to the base 10, I have to find this, then let me say that this is equal to x, then I am going to find 10 to the power of what it is going to be 100. Okay, I have to find this x. Okay, so these are the two things that you should keep in your mind. Fine. Will that be okay? Any problem?
No problem.
No, sir.
No problem. No problem. Okay, fine. Fine. Now you can see that. Now you can see that 10 to the power of 2, it is equal to what? 100. Right? 10 to the power of 2, it is equal to 100. Okay. Let me tell you one thing, and then we can we will derive one identity. Okay. Tell me what is log of 100 into 100. Base is still 10. बताइए. How many zeros? This will be converted into how many zeros?
Still 4.
This will be equal to 4. Yes or no? All of you tell me.
Yes, sir.
Okay. Now you are learning how to expand. If you have multiplication. Okay, if you have multiplication like this, now how can you expand this? So you will write this is equal to log of 100 plus log of 100. And let me show you how. See, log of 100 is how much? 2 plus log of 100 is how much? 2, which is equal to 4. And that is the same answer that we have got here. Yes or no?
Yes, sir.
Yes. Okay. So this is one of the rule that is known as the multiplicative rule. Multiplicative rule. So we have log to the base of a, and we have x into y. Okay. So this will be equal to log of base a x plus log of base a of y. Okay. Log y to the base a and log x to the base a. Fine. Now let us see what will happen. Let us see what is going to happen if I take log 100 upon 10. है ना? यहाँ पे the base is 10 here. So tell me, what will be the answer?
1.
The 1.
1. Yes, very good. 1. Okay. Acha, I hope all of you are understanding and you are not using calculator. You are giving answers on your own only, na?
Yes.
Yes, sir.
Okay, fine. 1. Okay. Now let us see what we can do here. We can write log of 100 minus log of 10. So if I write log of 100, that is equal to 2 minus log of 10, it is equal to how much? 1, and which will be equal to 1. Yes or no?
Yes, sir.
है ना? So this is the quotient rule. Okay, this is the quotient rule, which says that if I have log to the base of a x upon y, this will be equal to log of base the same a of x, that is numerator, minus log of base a and y. Fine. I hope you can see some similarity with exponents because it is just exponents only. A to the power of x into a to the power of y, which is equal to a into x plus y. Yes or no?
Yes.
Yes, sir.
है ना? So see, multiplication becomes addition. Similarly, a to the power of x upon a to the power of y, it becomes what? A to the power of x minus y.
Yes.
Right, everyone? Yes or no?
Yes, sir.
Yes.
है ना?
Yes.
Okay. So this is the quotient rule. This is the quotient rule. Okay. Now you tell me, guys, what is going to happen if I say log of base 10 100 square. This is going to be equal to
4.
4. Okay, 4. So I can write this as, okay, what will happen if I have log to the base 10 and 100's cube?
6.
Log of base 10 to the power of 4.
8.
8.
8.
Can you see some pattern here?
Table of 2.
Yes or no? What is log of 100? It is what? 2
2.
into 2. Log of 100 is 2. 3 into 2. And this is equal to 4 into 2. Can all of you see this happening?
Yes, sir. Yes.
है ना? Now this is the power rule. This is the power rule. Okay, this is the power rule. What is the power rule? If you have if you have log base 10, you have base 10 नहीं, generalize करने के लिए a x to the power of y. This will be equal to y times log of x to the base a. Okay, fine.
Yes, sir.
Any problem? Anyone?
No, sir.
No problem, guys, right? Yes
No,
or
sir.
no?
Yes.
No problem. Okay. Now you have to remember. Now let us try to do some logs. Let us try to do some logs. Okay. You have to be manipulative with the numbers. Okay. You have to be manipulative with the numbers. So I will tell you some log of 1. It will be always base is 10. Okay. All of the base that I'm writing here, it is 10. Okay. Please keep that in mind. Log of 1 will be equal to how much? 0. Yes or no?
Yes.
Yes. Okay. Fine. So if I will have something as log of 1 upon, let us say log of 1 upon 100. Okay. So I can write this as log of 1 minus log of 100. Yes or no?
Yes, sir.
Okay. By the quotient rule. And by the quotient rule, we can write it like this. Now log of 1, it is equal to 0 minus log of 100. Yes or no? Now I can say that this is equal to what? This is equal to minus log of 100. Yes or no? Guys,
Minus 2.
Yes, sir.
क्या हुआ उमर?
Minus 2.
हाँ हाँ वो आंसर -2 आएगा. I'm just writing about, I want to write a property. If you have log, a general thing that you need to remember. Okay, if you have log of 1 upon x, this will be equal to minus of log of x. Okay, and that is how we are defining the pH also, na? Because it is pH is what? Minus of log of concentration of H plus, and I am seeing that this is equal to the positive log of the reciprocal of the concentration of H plus. ठीक है नहीं? And this is what we have written na? For pH.
Yes, sir.
Okay, fine. So now log 1 is 0. Let us write a few more logs. Okay, let us write a few more logs.
You can scroll up.
Okay.
Done, sir.
Done. Okay. So let us, I'm writing log of 1, it is equal to 0. By definition, you don't have to worry about this. I'm giving you some log. Log of 2 will be equal to 0.30. Okay. Log of 3, it is equal to 0.48. Then log of 4, I can write that it is equal to log of 2 into 2. And then I can write it is the log of 2 plus log of 2. You will tell me the answer here. Okay. Now I will give you log of 5. This will be equal to how much? This is equal to 0.70. Okay. So these terms you have to remember. Log of 2 you have to remember. Log of 3 you have to remember prime numbers. Okay. Log of 4 you have, sorry, not log of 4. You can derive log of 4. Log of 5 you have to remember. then log of 6. So now you have to tell me how can I write log of 6 in terms of what we have given here.
2, 3.
2 into 3, right? 2 into 3. This will be
Log
equal
of
to
2 plus log of 3.
log of 2 plus log of 3. Okay.
0.30 plus 0.40.
नहीं नहीं यहाँ पे 0.30 plus 0.48 हाँ 48 ऐड करेंगे ठीक है. You calculate this, okay? You all calculate this. Simple additions है यहाँ पे आप तो. You don't have to do much. Then we have log of 6. Then you have log of 7 that you have to remember, because again this is a prime number. Reba, okay. Reba, Mariam,
Yes,
Surat,
sir.
हो रहा है ना? आ रहा है?
Yes,
Any
sir.
problem?
Yes, sir.
No, sir.
No problem.
No, sir.
Atif, no problem. Atif नहीं है क्या? अभिनव? आतिफ तो है,
Yes, sir.
अभिनव भी है. No problem ना? आ रहा है आपको?
Yes, sir.
Okay. So log of 7 you have to remember because it is a prime number. Then you will tell me the value of log of 8, which is log of 4 into 2, that is log of 2 plus log of 4. And then at last you will tell me the log value of 9. And log of 10 it is equal to 1. And because 10 to the power of 1 it is equal to 10. Okay? So you have to tell me for. Okay, so tell me for log 4 what is the value? I hope you have calculated for log 4 at least. 0.60. 0.60. Okay. What about log 6? Did anyone calculate?
0.78.
0.78. Okay. What about log 8?
0.90.
नहीं, एक तो ऐसे नहीं बोला जाता ना. We don't say it like this ना. 0.90 थी ना होता है. 0.90
0.90.
है ना. Okay. 0.90. 90 मत बोलिए. What about log 9? What about log 9? 0.96.
0.96.
0.96. Okay, so what I have did now, I have rounded up all of these things. So when you are multiplying this now 3 into 3, it should actually be 0.95, but it is 9.6. Okay, I'm just saying that this is not correct because I have approximated these values. Log of 2, 0.3, log of 3, 0.48, all of these I have approximated and told you. So all of these are right. Only in log 9, it is 0.95, but you don't have to worry. If I write the actual value, it is around, I think 0.954 or something, 95424 or something. Yeah, I think that is something like that. Okay, so it is quite near to 9.6. You can work with that. But again, I'm also telling you the more closer value is 0.95. Okay. But
Yes.
if you have 0.96, then also don't worry, you can calculate it. So log 10 तक हो गया आप लोगों से, है ना? Yes or no?
Yes, sir.
Now let us see how can we calculate if I have something which is a bit weird, है ना? Which is a bit weird. For example, let us see how will you write log 0.0036 if you have 0.0036. How are you going to do this? See, first of all, now what you have to do, you have to always convert in terms of whole number multiplied by whole number. Please remember, whole number multiplied by exponent of 10 if you have any decimal like this. So you will have two things, log of 36 into 10 to the power of -4. Yes or no? बताइए.
Yes,
Any
sir.
problem?
Yes, sir.
No problem. Okay. Order of magnitude. Okay, order of magnitude. Yeah. Then you can write log of 36 plus log of 10 to the power -4. Any problem? Any problem, guys?
No, sir.
No, sir.
No
No,
problem.
sir.
Then you can write this as log of, how can I write 36? 4 into 9
Yes.
or 6 into 6? How do you want to write it?
6 into 6.
6, sir.
6 into 6. Okay. 6 into 6. Now this -4 will come forward and it will become -4 into log of 10. Yes or no?
Yes, sir.
And this will be equal to log of
3
log of
into
no, this is 2 into log of 6. What is log of 6? Log of 6 square, and this will become minus log of 10 is equal to 1, so this will be -4. Yes or no?
Yes.
है ना? Now you tell me what is log of 6 square?
the
2 into log of
log of 6.
-4. What is log of 6?
Log
0.
of 2 into 3.
Log of 2 into 3 है ना? But I hope you can remember the 0.78 है ना?
Okay,
This is so 6 के लिए you have easy. एक मतलब you have 2 consecutive letters 6, 7, 8. If you remember 6, 7, 8, then you will remember log of 6 है ना? Log of 6 is 7, 8. I mean 0.7. 0.78 minus 4. Okay, 0.78 minus 4. Now this will be equal to what? Tell me. What will be this equal to? क्या हुआ?
So
7, 8.
minus
-2.44.
2.44.
अच्छा ये पूरा कैलकुलेट कर लिया आपको, मुझे लगता है -2.44 ना?
Yes, sir.
After subtracting 4, correct?
Sir.
Okay.
Yes, sir.
तो देखिए है थोड़ा है लंबा, but it is just manipulation of numbers. Yes or no? Guys, tell me.
Yes,
Yes,
sir.
sir.
है ना? It is just manipulation of numbers. अच्छा. Now, if you will practice on log, then it is going to be fine. Now, let us see how are we going to calculate? How are we going to calculate the antilogs? है ना? Antilog कहाँ पे काम आएगा? Because if you have pH, it is equal to what? It is equal to minus of the concentration of H plus, है ना? Minus of log of concentration of H plus. Now, you can see that this will be equal to something. This will be equal to some value, right? This will be equal to some value. Now, they are going to ask you what is the concentration of H3O plus. What is the concentration of H3O plus? Okay, so let me write it like this: log of minus of log of H plus. It is equal to pH. So this is power of 10, right? This is power of 10. Yes or no? है कि नहीं?
Yes, sir.
Sir, base of 10.
Sorry, base of 10. I am sorry. H plus, and I can write this is minus pH, right?
Yes, sir.
Then I can write that this is 10 to the power of minus pH. It is equal to the concentration of H plus. Yes or no?
Yes.
Yes or no, guys? So you will be given something as 10 to the power of -7. अगर pH आपको, if you have a simple pH like 7, 8, 9 something like this, then it is going to be easy. But if you have pH, let us say 2 minus, if you have pH, let us say pH it is equal to 2. Let us say 2.15. Okay, pH is equal to 2.15. So the concentration of H plus, it is equal to 10 to the power of minus of 2.15. है ना? Minus of pH, and this will be equal to 10 to the power of minus of 2.15. So how do we calculate this? What is this number? What is this number? How do we calculate this? That we have to study. Okay, that we have to study. So first of all, how we are going to do this? First of all, this is negative now. If this is negative, then what you are going to do in this case? What you are going to do? You are going to write it in some way minus 2.15. Minus 2.15. Okay, minus 2.15. So tell me, what is the nearest number after 2? Nearest whole number after 2?
3.
3. है ना? So I can write, आप ऐसे कर लीजिएगा calculate. 3 minus 2.15 कितना होता है? This will be equal to 0.85. Yes or no?
Yes, sir.
So I can write this as 10 to the power of 0.85 minus 3.
Yes.
Any problem here? No problem?
No, sir.
No problem. Okay. Then you can write this as 10 to the power of 0.85 into 10 to the power of minus 3. Any problem?
No,
No,
sir.
sir.
No problem. All of you? बताइए, no
Sir,
problem
No,
है?
sir.
Can you say how you got 0.85?
नहीं, ये देखिए ना, आप यहाँ पे हमने माइनस किया है इसको 3.3 minus 2.15.
Okay.
I've represented 2.15 as this number. Okay.
Okay, sir.
Okay. Fine. Okay. Now you have to listen. Now you have to listen. You 10 to the power minus 3 is okay ना? You have seen 10 to the power minus 3 previously, and we can write that scientific notation में ऐसे ही लिखा जाता है. So 10 to the power minus 3 is not of concern. The concern is 10 to the power of 0.85. Yes or no?
Yes,
Yes,
sir.
Tell
sir.
me.
Yes, sir.
This is our concern. This is how to write this. How to write this. Now the log comes. Now the log comes. What it is saying? It is saying that log of 10, है ना? Log of 10. There is some number here, right? We have to find the x here. Yes or no?
Yes,
Tell
sir.
me. So
Yes.
log of what is equal to 0.85? Near to 0.85, you tell me. What you see? 1 to 10 तक देखिए आप. Log of 1, 2, 3, 4, 5, 6, 7, 8. आप सब कुछ देखिए और फिर बताइए हमें what log of what is equal to 0.85? Yeah, log of what is equal to 0.85? Approximately.
7 is very close.
7 is very close, है ना?
Yes, sir.
7 is very close. So you can write this as 7 into 10 to the power of minus 3. आया?
Yes.
आया? तो okay, fine. यहाँ से यहाँ कुछ ज्यादा ही आसान हो गया, but you understand this ना? Tell me.
Yes,
Yes,
sir.
है ना? So you see, you have to follow the process. You have to follow the process. एक चीज तो तय है कि what we are going to use ना, we are going to use the anti-logs, है ना? We are going to use the anti-logs. ऐसे ही होगा. We'll have to calculate the concentration of H plus, and this will be equal to 10 to the power of minus of pH. And you know that the pH, it is ranging from what? It is ranging till 14. So pHs are all what? They are all positive numbers. That means always you will be getting 10 to the power of minus something. 10 to the power of minus something. So if you have 10 to the power of some decimal points, na, let us say some decimal point minus x, okay, and x is a decimal, x has some decimal points, then you will do add a number just after a whole number, just after x, you will represent x according to that number, then you will do what we have done here, right? Then you will do what you have done here. The point is you have to get a 10 to the power of something which is less than 1, right? Which is between 0 to 1, because we know only log of 0 to 1. देखिए ये 0 से start हो रहा है यहाँ पे and it is ending at 1. Okay, so if you have anything which is 10 to the power of 0.30, this is equal to 2. 10 to the power of 0.48, it will be equal to how much? This will be equal to, tell me.
3.
Huh? 3.
3.
Right? So these are the things that you have to remember. Okay.
Yes, sir.
Okay. So are you guys a bit comfortable in log now?
Yes, sir.
Yes, sir.
Okay, fine. ठीक है, मैथ भी हम ही से पढ़ लीजिए आप लोग. चलिए, let me stop sharing.